Hello everyone, welcome to today's mathematics class. In today's class, we are going to continue with solving this integration problem. So let us learn it from the scratch. I am going to be very slow for the sake of the slow learners in a class. So if today is your first time of coming across my page, just consider following and also like and share this post. As you do so, God will bless you. This question is actually an advanced mathematics. We are asked to integrate function like this. So when I look at this question in the first place, I was puzzled anyway. I began to think which method are we going to use. And this one is not integration by parts. This is neither integration by partial fraction, but every problem in mathematics has a solution. Now let us carry out some manipulations. Before we can solve this problem, we are going to make sure we work towards eliminating either this or this. We are going to use substitution along the line. But before we can use substitution, we cannot just use substitution here directly. We need to first of all rearrange the question. Now let us rearrange the question. You know that this one here is distributed to both this and this. And at the same time, it can be distributed to just one of them, and this other one will multiply. It's still the same thing. Now, it can be arranged as this. We have x plus 1, then all over x, like this. Okay, I am coming. Then it will multiply the whole of this one. We have x plus log x all squared, then dx. Good. Now we have carried out one step. Let's move to the next step. The next thing we are going to do now is to distribute what we have here to what is inside, both x and this. So we distribute this x here is a common denominator to x and also to 1. So which means I'm going to distribute it now. Become x over x, then plus 1 over x. Then we are multiplying what we have here, x plus log x all squared. Then you bring your dx here. So if this one goes here, it gives us 1. It now gives us 1 plus 1 over x. Then multiplying x plus log of x all squared, then dx. So at this point now, we can use substitution. So let us try to substitute for this. We cannot substitute for this here. So let us try to use anything to represent here. We can use u. We can say, let u equal to x plus log x. Just what we have here. Okay. Now, we are going to differentiate. Remember, in integration, whenever you carry out substitution, the next thing you do is to what? Differentiate, find the derivative of u with respect to x, so that our aim is to come and replace this dx. That is the essence of using substitution here. Now, what we are going to do now is to find the derivative of u with respect to x. We have the u dx equal to, if you differentiate this, will give us 1 plus. Now, this log we are seeing here is 1 with base e. Okay, though it's not denoted here. It's a natural logarithm. Now, when you differentiate a natural logarithm, it will give us 1 over x, then to the log of e to base e. And of course, in mathematics, the log of a number to the base of that same number, it will be 1. So this one will be cancelled out here. So this is your base. So at the end now, we can then look for the x. If you cross multiply, we're going to have du equal to what? 1 plus 1 over x, then multiplying the x. Good. So which means this du now will come and replace this one here. What we have here, this and this. Okay, look at it here, this one and this one, because we can rearrange. We can bring this one first, can bring this one to the next one. So look at what we are going to have now. We're going to give us something like this. Let us rearrange this now, because this one is now u. Okay, so to now give us u square because of this square here. Then we're having 1 plus 1 over x. Then dx, assuming we have not substituted for this. Now we have not substituted though. Let me show you why I am going to trash this away. So if you notice now, we have 1 plus 1 over x, the x here. Now look at it here. This same 1 plus 1 over x, the x is equal to du here. So which means in this place, we are going to put du here. No longer 1 plus x, the x is no longer there. So let us clean it. So at that point, this will not just give us du. Now let us now integrate. Remember integral, to integrate means we add 1 to the power, then divide by the results, which means we're going to have u equals to 2 plus 1 all over 2 plus 1, then plus what? The constant. So this will now give us u raised to power 3 all over 3 plus constant. And of course, remember that what? Your u is equal to what? X plus what? Log x. That is it. So in that case, we are going to replace it here. It will now become 1 over 3 bracket what? X. U is what? X plus log x, then plus c. That's all. That is the final answer. Oh, sorry. We have this power here. Don't forget, you must put the power. Look at, because u raised to power 3 here, then plus what? C. That's how we integrate this kind of question. It's very easy. So I did a paperwork on it. Some of us did not understand, so I decided to use video explanation. I hope you understand this topic. If you find this class very interesting, help us to share this post to get to greater number of students. Bye.